Hi everyone, welcome to week 8. We're going to start a new topic today, and this week we're going to be focusing on radical expressions and functions. So, last week we finished talking about rational expressions and functions. Today we're going to deal with radical expression and functions. Now, first of all, the operation of applying a radical is the inverse of the operation of exponentiation. Where inverse, an easier way to understand this is opposite. And for example, addition, the opposite is subtraction. Multiplication, the opposite is division. So something along that line. Example, another example is square root. So 5 squared is 5 times 5 is 25. And in terms of inverse operation, we say square root of 25 is 5. And this symbol is called the radical sign. In particular here, it's called square root. The number inside is called the radicand, and the entire expression together is called the radical expression. Principal square root. If a is a non-negative real number, the non-negative number b such that b squared equals a and b is the square root of a is called the principal square root. Or in simpler terms, we only consider the positive square root and we call it the principal square root. Okay, I'll come back to this caution. I'll give you an example of the principal square root. Let's say example, square root of 100. We know it can be 10 or negative 10, but we are only going to consider the positive one because that's the principal square root. Now, point of caution here, square root of x plus y is not equal to square root of x plus square root of y. This is a very common mistake, and you can check that it's not true. If you take x is 36 and y is 64, square root of x, that's square root of x is 6, square root of y is 8, and 6 plus 8 is 14. But square root of x plus y is square root of 100, which is 10, and these are not equal. Let's look at some examples. Let's start with this easier one. So square root of 49 is 7. So this is negative 7. This we're going to say is not defined. Well, because square root cannot take negative numbers, right? For example, if you say 5, well, 5 times 5 is 25. So it doesn't work. No. And then if I say negative 5, well, negative 5 times 5 is also 25. So it doesn't work as well. Here, you have to be a little careful. First of all, observation is 81 means it's some power of 9, right? It's 9 squared. I can rewrite this as a fraction as 81 over 10000. Square root of this I notice is 9 squared, and this is 100 squared. So this becomes 0.09. Maybe I write this step in between. It's 9 over 100, which gives me 0.09. Okay. Square root as a function. Well, recall, right at the beginning of the semester, we talked about what is required for something to be a function. We need a unique output for each input. So for y equals root x, when evaluating, we restrict to only positive values. Example, y equals root x. If x is 36, then square root of 36 is 6, not 6 and negative 6. Let's look at an example. Evaluate this function at 2. So f of 2 means I replace x by 2. Sorry. That's going to be square root of 10 minus 6, which is square root of 4, and that's only going to be positive 2. Okay, not the negative. Now here the negative sign is outside, so I have to be careful. G of negative 3 is going to be minus 64 equals minus 8 times negative 3. So I retain the negative sign outside. This is plus 24. Is that correct? Yeah, that's correct. So it's negative of square root of 88, and I can let it be as it is. Domain and range. Obviously, x cannot be negative, so the domain is 0 to infinity, because square root of 0 is defined and it's 0, so that's fine. Range can also be negative, cannot also be negative, so the range is also the same, 0 to infinity. Example, find the domain of this function. Well, we require that this thing has to be greater than equal to 0. So I have 3x plus 12 greater than equal to 0. We've learned how to solve this type of inequality, x greater than equal to negative 4. So the domain is negative 4 to infinity. In fact, you can check. If I plug in x equals negative 5, the inside part of the square root is going to become a negative number. Okay, that's it for this video.